Hello everyone, let us continue with Indices chapter. In the previous session, we had discussed certain questions from exercise 7a. Now let us have a look at the remaining questions. So this is from question number 2 of the exercise. This is subpart 3, okay, the question. Now I'll have a look at this question. This is a very classic question, I would say, because over here the values that are there, if you understand the concept of this particular question, no, you'll be able to solve most of the questions of this given exercise. Okay, now what are we given over here? 5 raised to the power n plus 3 minus 6 into 5 raised to the power n plus 1 upon 9 into 5n minus 5n into 2 square. Now what are we going to do is we need to take out something common over here. Okay, now what common are we going to take out? This value over here, 5 raised to the power n plus 3. Okay, understand this over here. If you have, how had we got this, like how did we reach to this value? This can be broken down as 5 into n, 5 raised to the power n into 5 raised to the power 3, correct? This is how we have arrived to 5 raised to the power n plus 3. Remember, we had a rule of indices that if the numbers have the same base, in that case we are going to add the powers for multiplying such values, right? So using the same concept, we need to break or split this 5 raised to the power n plus 3. So 5 raised to the power n plus 3 can be broken as 5 raised to the power n into 5 cube minus 6 into. Now another thing over here, even this value, that is 5n raised to the power 5 raised to the power n plus 1 can also be broken as 5 to the power n into 5 to the power 1, or you can just simply write 5 upon 9 into 5 to the power n minus 5n into 2 square. Now what you can do is, you can see clearly that we have 5n over here in the numerator, and in the denominator also we have it, so we can take it out as common so that we can cancel it out. So 5n can be taken common. What will remain inside? We have 5 cube minus 6, okay, multiplied by 5n is common, right? So this has gone out. We are left with 5 to the power 1. And same way below we have 9. Again we can take out 5n common. What are we left with? We're left with 9, because this 5n has gone out, minus this has gone out, right? We're left with, okay, so over here we can also write it as we are left with 2 square over here. Okay, now this 5n and this 5n is cancelled. You are left with 5 cube. 5 cube is 125 minus 6 into 5, that is 30 upon 9 minus 2 square. 2 square is 4. Okay, then 125 minus 30, how much are we going to get over here? 95 upon 9 minus 4 is 5. Solve this. 95 divided by 5, right? We have this value is going to be equal to 19. Okay, so the answer will be 19. Okay, now let us see question number 4, subpart 3. This is 32 raised to the power minus 2 by 5 divided by 125 raised to the power minus 2 by 3. So first of all, we are going to break 32. Okay, by factorizing it, I'm doing prime factorization of 32. I'm going to get 2 into 2 into 2 into 2 into 2. That means 2, how many times? 5 times. Okay, raised to the power minus 2 by 5. Now I have already taught you what is the logic of breaking this. We have 5, right? In the power, we have 5 in the denominator. If we express 32 also in the power of any such that we get a number having power 5, then that 5 and 5 can get cancelled. Okay, that is the basic logic. Now similarly, you have 125 raised to the power minus 2 by 3. That means we are going to break 125 such that we have a number that has the power 3. So that is, you factorize it, you get 5 into 5 into 5 raised to the power minus 2 by 3. Now how many times are we having 5 over here? I mean, how many times are we having 2? 5 times, right? 2 to the power 5 whole raised to the power minus 2 by 5 divided by 5 to the power 3 whole raised to the power minus 2 by 3, right? Now power into power is always multiplication, so we have 2 to the power 5 multiplied by minus 2 by 5. This 5 and this 5 gets cancelled. This is what I've been talking about. And we have 5 cube multiplied by minus 2 by 3. This 3 and this 3 are cancelled. Hence we are left with 2 to the power minus 2 divided by 5 to the power minus 2. Okay. Now we have also learned a rule that if we have different bases and we want to multiply or divide but the powers are same, in that case we can take the power as common. So what do we have over here? We have 2 divided by 5 and this power, that is minus 2, can be taken common. Okay, then what are we left with? We are left with another step. Basically, what do we have? 5, let's take the positive power, so this will be 5 by 2 square. 5 square is 25 and 2 square is 4. Answer will be 25 by 4. Now look at this particular question. This is question number 3, subpart 4. This is a very important question. I would say it's one of the most important ones from this particular exercise at least. So we start by solving the inner bracket. Okay, this is the inner bracket. So what do we have over here? We basically have 1 minus 1. The remaining things will be as it is. So we have 1 minus n raised to the power minus 1. If you take the positive power, we will have it as 1 upon 1 minus n. Correct? Till here I think it's simple enough. And then we are left with this bracket minus 1 whole raised to the power minus 1. Okay, let's see in the next step. Again we're still solving. Now we'll be solving this entire portion because this inner bracket is already done. Now if you take the LCM, what will it be? It will be 1 minus n. So this 1 minus n will be multiplied by this 1. Okay, because we're taking LCM. So we'll get 1 into 1 minus n will give you 1 minus n only, right? Minus 1, and this entire value is upon 1 minus n raised to the power minus 1 raised to the power minus 1. Now we try solving this. what are we going to get? 1 minus 1. We are left with minus n upon 1 minus n raised to the power minus 1 and whole raised to the power minus 1 again. Now we are solving this portion. This is negative power, turn it into positive. What are we going to get? We are going to get 1 minus n will come on top and this minus n will come down. Okay. Now the negative value of the power is gone, and then you're left with this whole bracket minus 1. Okay, just a thing. We are left with, let's keep this negative power here only, okay? Let's say we have n only over here. Let's keep the negative power on top. Now what will happen? 1 and then this minus is there, okay? For both these values. See, I've just made a small change over here. We had shifted minus n down, okay, but no, we'll just put n down and the remaining minus sign, the left minus sign, that will be as it is, okay, and 1 minus n will be going on top because we are taking the positive power, okay. Now minus minus is plus and you're left with 1 minus n upon n whole raised to the power minus 1 is equal to, we want to solve this part, again we'll be taking LCM. LCM will be n, so n will go, n will be multiplied with 1 over here, so we'll get n only, n plus 1 minus n, and the whole thing is raised and upon n whole raised to the power minus 1. This n and this n will be cancelled, left with 1 by n. Sorry, there's no negative sign, okay. You are left with 1 by n and this whole thing is raised to the power minus 1. So take the reciprocal, you are going to get the value as n. So the final answer is n for this question. I hope you have understood.